All right, so this is just a quick lesson on how to use scale diagrams to find images for mirrors. I assume that when we're talking scale diagrams, we're looking at this one assignment that has 4 questions on it that asks you to use a scale diagram to find the image in various mirrors, as well as using calculations to find where the image would be and the image characteristics. So to do the scale diagram, all I need to know is that the object distance is 15, the focal length is 5, and the object height is 5, and that it's a converging mirror. I guess I need to know that as well. So just to start, I'm going to move this over here, and I'm going to put this right here, just so I don't forget what some of these parameters are. So obviously, this is going to look better on your page when you do it, but if I just move this back here. So since I don't think I can draw a nice straight line on this, I'm going to have to freehand it. So I'm making myself just a principal axis here. And as far as a scale diagram goes, you just have to say something like this: 1 square equals 1 centimeter. I'm going to draw myself a converging mirror, like so. And if 1 square equals 1 centimeter, then the focus, actually, no, I don't want to do that. I want to do 1 square equals 5 centimeters. There we go. That means that the focal length, again, I can't remember what the focal length is. Let's go back to it. The focal length is at 5, and the object distance is at 15. Now, maybe I'll even adjust that. Let's say 1 square is equal to 2 centimeters. All right. So then I go 2, 4, 5 centimeters are right here. There's F. And then I got to go another 2.5, and that would get me to C. So there's my key spots. If I want to go to 15 centimeters, it's going to be each square being 2 centimeters. It's going to be 2, 4, 6, 8, 10, 12, 14, 16. So 15 centimeters would be right here. And it says it's 5 centimeters tall. So that would be about this tall right here, right to that 2.5 squares to 5 centimeters. So that's how you set up a scale diagram. Then you're just doing your ray diagrams like you were before. And I'm going to freehand these, so these are going to look quite ugly. On yours with a ruler and graph paper, it'll look much, much better. So I'm going to do them in maybe some different colors here. So same as before, a beam parallel to the PA should reflect through F, like so. Switch to blue, a beam that goes through F should reflect parallel to the PA, like so. And then our image arrow tip should be right here, right there. So what did we gain from that scale diagram? Let's see. Well, it's how many squares away? 1, 2, 3, 4 squares away. So I would say my image distance is at 8 centimeters. Why? Because each square is supposed to be 2 centimeters, and it's 1, 2, 3, 4 squares away. My image height is equal to about 2 and a bit. Yeah, I'm going to go with 2 and a bit. Maybe even just 2 if I look at how that beam goes. If I'm thinking that's 2 squares of height, 2 times 2 centimeters is a 4 centimeter image height. So this isn't, I freehanded this diagram. This looks ugly. If you were to hand something like this in, you would lose lots of marks because you very clearly have not used a ruler. You're going to get better results if you use a ruler. So the point of it is to compare it to the calculations. So let's see what the image distance should have been if I go 1 over di plus 1 over do equals 1 over f. So 1 over di is equal to 1 over 15 plus, not plus, 1 over di plus 1 over 15 equals 1 over 5. Or 1 over di equals 1 over 5 minus 1 over 15. You do that on a calculator. Since I don't have a calculator on me, I'm going to change that to 3 over 15. So that's going to be 2. 3 minus 1 is 2 over 15. And then flip it to get your answer, and DI should equal 7.5 centimeters. So that's actually pretty close. If you look at what my scale diagram got me, it said an image distance of 8 centimeters. And the calculation that should give me it just perfectly exactly is 7.5. So I'm pretty happy with my scale diagram for that. All that stuff I did with the common denominator and that with the fractions, you guys would do that on a calculator, so don't worry if you weren't able to follow what I did there. The other thing is the magnification, which is negative DI over DO, which in this case is supposed to be negative 7.5 divided by the object distance, which was 15. So that is negative 0.5 for magnification. What that means is that the image should be inverted, which we did get, and half the size. 0.5 means it should be half the size. In any event, let's see if I use that magnification equation again, but for image height over object height, then I get negative 0.5 now equals image height over the object height was 5 centimeters. And if I go 5 times 0.5, I get 2.5 centimeters, actually negative 2.5 centimeters as my image height. So on that front, my scale diagram failed me greatly, as I got an image height of 4 centimeters, and the calculation told me that it was supposed to be 2.5 centimeters. Of course, that's a result of me not using a ruler and doing what I would call a terrible looking ray diagram. That does not look great. I've marked quite a few of these now, and nobody's looks this bad, nobody in the class. So this is the worst one I've seen, and it still got me pretty close, at least on the image distance. Anyway, that's the only difference from regular ray diagrams, is setting that scale and saying something to the effect 1 square equals 2 centimeters. Or you could have, I think in class I went 1 square equals 5 centimeters, which put everything much closer together. I used a ruler in class, and it worked out actually pretty well. A few students got it to work even better than me, but mine worked out well also. If there are any more questions about any of those, so that basically gives you what I would expect to see for this one right here, where it says a converging mirror has a DO of 15 and a focal length of 5, and the height of the object rather is 5 centimeters. Find DI and magnification, and then use a calculation to compare and describe the image using SALT: size, attitude, location, and type. Number 2 says do the exact same question except use a diverging mirror, which means you would have to just draw the mirror the opposite way and then go through the same process and do the same calculation and all that stuff. And then the other 2 questions just give you some different mirrors to play around with. That's all there is to those. If you have any trouble with them, just let me know, and I can send up some more examples. I think that's going to be it for now. Good luck.